So we're in section 8.2. Did I start that? I did start that.
Yeah, that's where I was going. First place.
Uh-huh. All right, so arithmetic sequences are very nice. They're very friendly. The rules are very friendly. The rules are nice. They work. They work nicely. So first, let's talk about what an arithmetic sequence is. We get each term by adding to the previous term. So that's why we call it arithmetic, because we're adding. So the way we write that, and the other way that we say it, the more common way to say it, this is the everyday way we think about it, we add to a previous term. There is a common difference between each term, between each pair of terms. So I'll say between terms. So in symbols, we would say a sub n is a sub n minus 1, the previous term, plus some common difference. And the reason we call it the common difference is we could also write this, subtract the a sub n minus 1 from both sides. A sub n minus a sub n minus 1 equals that common difference. So if we subtract any two consecutive terms, we get the same number every time. So that's why we call it the common difference. We get each term by adding something to the previous term. So it's very easy to decide if we have an arithmetic sequence. The pattern is easy to see. So for example, you might be asked, decide if this sequence is arithmetic. Or is the sequence arithmetic? If so, state the common difference. So I'm just going to say arithmetic, question mark. So we're saying, is it arithmetic? And then we want to find, if so, the common difference. All right, so here's our first one. 5, 8, 11, 14, ... Would that sequence be arithmetic?
Yes.
Yes. What's the common difference? 3. Easy to see that. How about this one? 15, 11, 7, 3, ... Yeah. Our common difference can be negative. Our terms can get smaller and smaller. And we just keep subtracting -4 to get the next term. All right, so easy to tell if we have an arithmetic sequence. Well, the fact that it's easy to tell that there's an arithmetic sequence, the rule to get the next term is very easy. Lets us come up with a formula for the nth term that's nice to work with. So let's talk about that. The nth term formula. And this is easy enough that we're going to figure this formula out. We are. And at the end, you'll all say, hey, that was easy. A sub 1 is just A sub 1. You just start with some first term. A sub 2, we get the next term by adding the common difference to the first term. A sub 3 is A sub 2 plus D, but A sub 2 is A sub 1 plus D plus D, A sub 1 plus 2D. A sub 3 is, A sub 4 is A sub 3 plus D, but A sub 3 is A sub 1 plus 2D plus D, so we get A sub 1 plus 3D. Do we see the pattern? A sub n would then be A sub 1 plus n minus 1 times D. So we can get any term of our sequence. We just need to know the first term and know where we started. And then we need the common difference. Plug it in and we have our term.
Wow, Mr. Beamer, that was easy.
Yeah. So there's our nth term formula. So let's look at a couple of examples using the nth term formula. Let's say we want the nth term. I'm going to tell you it's an arithmetic sequence. Where D equals 5 and A sub 1 equals 9. So this is just a matter of plugging into the formula. A sub n is A sub 1 plus n minus 1 times 5. And usually we distribute and simplify, so this would be 5n minus 5, so we get 5n plus 4 is usually how we write that. So that would be our nth term of that sequence. Plug in, and we have our term. Well, let's look at a little more interesting example. Let's find the nth term. We have an arithmetic sequence where we have the fifth term is 19 and the ninth term is 27. So there's an intuitive way to do this. The intuitive way is a little more difficult if the terms are further apart. So we had the fifth term and the 575,000th term. So on a test, I will ask you to do this algebraically. So we know that a sub 5 is a sub 1 plus n minus 1. Fifth term, n minus 1 is 4, d. And that equals 19. And a sub 9 is a1 plus 8d, and that equals 27. Well, here we have a visit from an old familiar friend. What do we have here? A system of equations. We have two variables, two unknowns. We have a sub 1 and we have d. Well, this one is nice because we just subtract the second so the first from the second, because the coefficients on these are the same. Subtract, and we get 8d minus 4d is 4d. 27 minus 19 is 8. So d equals 2. And now I'm going to plug that in here. So I'm going to circle that one in green. I can plug into either one of these, but I can say a1 plus 4 times 2 is 8 equals 19. So that's plugging into that first equation. So that tells me that a1 equals 11. So a sub n is 11 plus n minus 1 times 2. And we'll distribute and simplify, so that would be 2n plus 9. And that would be our formula for our nth term. And this setting up a system of equations is going to be helpful for when we talk about a geometric sequence, because we'll set up a system of equations, but we have to use a slightly different technique for solving that one. All right, questions there? Well, because arithmetic sequences are really nice, because our formulas are really nice, it's easy to find a sum. If we want to add together 375 terms, it's easy to find a way to find that sum. So let's look at that. So we want to add together some terms. We could call it an arithmetic series, I guess, if we wanted. And the formula for our sum is pretty easy, so we're going to figure it out. So the nth partial sum, if we want to add together n terms, I'm going to write it out here. It's a1 plus, the next term is a1 plus d. The next term is a1 plus 2d. The next term is a1 plus 3d. And then we're going to go plus dot 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 all the way out to the nth term. And here now we're going to be clever, and we're going to write this in reverse order. So I'm going to start with a sub n, and I'm going to go backwards. Well, to go backwards from the biggest term, I'm going to subtract the common difference. So I'm just kind of going backwards, and then we go all the way down to a1. Well, then we say, there's something interesting that's happening there. We're going to add these together. So s sub n plus s sub n is 2 of those, 2 s sub n's, equals, when I add these two together, I just get a1 plus a sub n, plus, I have a plus d and a minus d. When I add those together, that goes away. A sub n plus a sub 1 plus a sub n. Here I have a 2d and a minus 2d. When I add those together, I get a plus a1 plus a sub n. Same thing here. And I get a plus dot 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 a1 plus a sub n. And I've done this, and we have n terms. We've added n of those together. Yeah.
Why do you add the two numbers together?
To get these d's to cancel out.
Okay.
Well, now, what's if I add something together n times, so if I add 2 to itself 8 times, what is that? What am I doing? Multiplying. So this is 2s sub n is n times a1 plus a sub n. Or the sum, which is what we're looking for, is n times a1 plus a sub n divided by 2. And that is our sum of an arithmetic sequence. We add the first term to the last term. Those are easy to find because we have a nice formula. We multiply by how many terms we have and divide by 2. Now, the math legend goes that the famous mathematician Gauss was in primary school, elementary school, and this was in the 1700s, 1800s, where they all have all the students have chalkboard slates, and the teacher so this elementary school gave them a task to keep them busy while he was doing something else. Said to add the first 100 numbers. 3 plus ... He thought it would take them a long time. Well, the legend goes that Gauss realized that 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101. So what you have is the first term plus the last term, and you do that however many terms you have, and you have to divide by 2 because you're doing them in pairs. So the legend has that he came up with the answer really quickly and showed it to the teacher. The teacher thought he got lucky and had him do another one, and he figured out the formula and did it really quickly again. So that's the math legend about this. So we had to wait until advanced pre-calc to figure it out. Gauss figured it out in elementary school. All right. So let's look at a couple of examples of this, and then I'll show you how to use your calculator a little bit. So we want to evaluate sum n equals 1 to 20 of 7n plus 1. So the first thing we want to do before we use our formula is decide, is this arithmetic? So let's look at a couple of terms. A sub 1 is 7 times 1 plus 7, which is 8. A sub 2 is 7 times 2 plus 1, so that would be 15. A sub 3, 7 times 3, 21, plus 1, 22. Is that arithmetic?
Yes.
Yes, D equals 7. So the answer is to arithmetic is yes. So we can use our formula. So we're adding 20 terms together, 1 to 20. A sub 20 is 7 times 20 plus 1, which is 141. So our sum, 20th partial sum, would be 20 because we're adding 20 terms. 8 plus 1, 41, divided by 2, which is 1490. If you do the problem like this, where you're finding the sum of an arithmetic sequence, and your sequence involves whole numbers, you should not get a fraction for an answer. So that would be a sign that you did something wrong. All right. Questions there? Another way you might be asked a question like this is to find the 15th partial sum of 2, 5, 8, 11, dot, dot, dot. So the first thing we should do before we use our formula, we should decide, is this arithmetic? Is there a common difference? Yeah? D equals 3. So this is arithmetic. We can use our formula. If it were not arithmetic, what we would have to do is figure out, like some of our homework problems, figure out a formula for the nth term, and then write out 15 of them and add them together. But because it's arithmetic, we have a nice formula. So I'm going to say yes, D equals 3. A sub 1 is 2. A sub 15, we need to calculate. That's A sub 1 plus 14 times 3, and minus 1 times D, which is 44. So our 15th partial sum is, we're adding together 15 terms. 2 plus 44 divided by 2. And when we calculate that out, we get 345. Would an infinite arithmetic sequence have a sum? A finite sum? No, because we're constantly adding numbers that are getting larger in magnitude. All right, questions? Okay, let me show you how to do a couple of things in your calculator. There was a problem on the homework. There might be a problem like that on this homework, where it asks you to use the table in your calculator to find the terms of a sequence. So what you want to do with that is, let's say the sequence is n, so I'm just going to do an x times x minus 1, and that's the terms of that's the nth term of my sequence. So I'm just going to put in my y equals x times x minus 1, and then I'm going to go to my table. There's the first term. There's the second term. There's the third term. There's the fourth term. There's the fifth term, etc., etc. So you can look at all the terms in your table. So your calculator will calculate out your terms. Your calculator will also calculate sums. So if you have a newer calculator, you should be able to do math. So hit the math button, and then 0. If you have an older calculator, does anyone not have math 0 on their calculator? So you get like an equation solver or something? Okay, so for those of you that have the equation solver, I'll show you how to do this in just a second. It takes a little more work. But let's say we want to sum. You don't?
Wait.
Okay.
No, I don't.
Okay, so I'll show you how to do that in just a second. So math 0, so let's say we want to sum. I'm going to say x. I'll use that instead of n or I. X equals 0 to 100 of 0.5 to the x power. So that would be like 1/2 to the x, 1/2 to the I. And then we hit enter, and it tells me that is 2. So that's 0.5 to the 0 plus 0.5 to the 1 plus 0.5 squared, etc., etc., etc. 100 times. If you do not have math 0, You have to go through a few more steps. So we're going to go to the list button, so second stat. And then you're going to go over to math. And number 5 is sum. And then you're going to go to list again. So second stat. And we're going to go to options. And we're going to go to 5 again, sequence. Now this calculator, on the little bit newer ones, you get this. If you don't get this, then you're going to fill in the same information, but just in a slightly different format. So I'll tell you how to go through it. Your expression is just the nth term. So we said we wanted that to be 0.5 to the x. All right. So 0.5 to the x, that would be the first thing that you enter. Do you just have parentheses? Yeah, if you just have parentheses, you'd enter 0.5 to the x, comma, and then you have to enter the variable. Comma is above the 7. The variable is x. Then you do comma. And then you have to do the start. So we started at 0, comma, end, 100, comma. And then the step size, we want the step size to be 1, 1. And then you close your parentheses above the 7. Yes. So when you're done, it should look like this. Sum, sequence, 0.5 to x, comma, 0, comma, 100, comma, 1, and your parentheses. It's right above the 7. Your comma is right above the 7.
So it's expression, variable, what's after?
The starting number, because we wanted to go from 0, starting number, comma, ending number. And then we want the step size to be 1. We're going up 1, 0, 1, 2, 3, 4, 5, etc.
Okay.
And then you hit enter. And this tells me 2. All right, and if you will not need to do this. You will not need to do this on a quiz or a test, but you can use this to check your work on your homework. If you need help putting it in your calculator, I can help you out. And your expression can be any kind of expression. It could be x to the n, or 0.2 to the n over n factorial, any expression you can put in there. All right, we good? Okay. And that homework last night was not that bad, was it?
It was pretty bad.
Even though it looked like a lot.
It was long.
When you were doing it, you said, "This isn't bad." Thank you, Mr. Beamer. I like that we're doing these problems. I wished I could do some more.
You can do it.
I've done them so many times.